Okay, actually video button is not pressed and I teach everything, and when I saw the button is not pressed because a call is coming and the video has stopped, so I have to teach this again. Okay, let's see what is the direction of magnified lines around a circular coil. It is told that the magnified lines or the line of force is straight at the center of the loop and parallel either side, right? And the parallel lines of forces, these line of forces curved or circled when it goes away from the center, right? And it takes the form of a whole circle, right? And these parallel lines are in the plane perpendicular to the coil, perpendicular to the loop. And what about here? As we know, if we have a loop and this is the point, then a small part is a straight part. It is almost straight. So, and you know the magnified pattern around a straight wire is circular. So this is a straight wire and the magnetic fields are in the pattern of circles, this side and this side also. Now we know what is the direction of magnetic field lines. As I have stated, the right hand thumb rule apply here, because the current is going downward here, right? The current is going like this. So in this section the current is going downward. So when it goes downward, then the direction of direction of the fingers to encircle the wire is like this, and this is the clockwise. So the direction is clockwise direction. Then the magnified lines have direction of clockwise, and here it is opposite to that. So the current is going upward, and the direction of magnified lines is anti-clockwise, right? Okay, so this is the line of forces around the circular coil, and I have not scattered Maxwell's corkscrew rule. This is very similar to the right hand thumb rule, but this rule is very important when I want to know the direction of magnetic field or direction of magnetic lines of forces. When we know the direction of current, अगर हमें करंट डायरेक्शन पता है, अगर मुझे मैग्नेटिक फील्ड लाइंस की डायरेक्शन पता करनी है तब भी ये पता कर सकते हैं, या मैग्नेटिक लाइंस ऑफ फोर्सेस की डायरेक्शन पता है, करंट डायरेक्शन पता करनी है, राइट? Okay, when we know the direction of magnetic lines of forces, so I have written a simple question for you. Okay, a straight wire AB. I have given a straight wire AB, and the magnetic lines of forces, and we know that the pattern around a straight, the pattern of magnified lines around straight wire is circular. So this is a circular pattern, and I have given you the direction of magnified lines, and the direction of magnified lines is anti-clockwise. This is going like this. This is the direction of magnified lines. So this is anti-clockwise, and I have to tell, you have to tell the direction of the current in the current carrying wire. Okay. To know the direction of current carrying wire, we can use Maxwell's corkscrew rule. Okay, let me tell you the brief history of the corkscrew. In earlier times, bottle of wine has a wooden cap that is cork. The cap is on the opening mouth of the wine. When someone want to drink the wine, then the cork has to be opened. It is very interesting, right? Okay. To open the cork, a screw is given. A simple screw like this. This is the handle. This is the spiral part. This is the head, and the head is very sharp and very thin, right? Screw is tapped in it or pressed in it so that this part pierced into the wooden cap. Now to open it, handle is rotated and pulled out the cork easily, right? Okay, so that's why this is Maxwell's cork screw rule. This right hand thumb rule is very similar to the Maxwell's cork screw rule, right? The direction of current is directly known by the vector laws, but this is given for a small child. For to the children of higher education, like class 10, right? In your upcoming classes, this is only rubbish. Right hand thumb rule, claiming left hand rule, claiming right hand rule, all things are rubbish. You can easily tell the direction of two vectors, right? Let me okay. Now concentrate here. Okay. So if you want to know the direction of current in section AB, in the straight wire AB, what we have to do? We have a cork screw. Okay. The direction in which we rotate the handle of the screw is the direction of magnified lines, and the head of the screw is and the head of the screw in which let me correct this. In which direction the head of the screw moves is the direction of current. It represents the direction of current, right? So we know the direction of magnetic field. This is anti-clockwise. This is anti-clockwise. This is anti-clockwise. So we rotate the handle of the screw in the anti-clockwise direction. Then what happens? See here. If we rotate the handle in anti-clockwise direction, what is happening here? The marker goes up. It means the screw, the head of the screw going upward, and in which direction the screw moves represents the direction of current. It is moving upward. It means in that segment, in that wire, the current is moving from B to A, right? If you want to know if a question is like this: a straight current carrying wire, and the direction of current is given A to B, then what is the direction of magnetic lines of forces? This rule by this rule we can apply this rule to know the magnetic field direction, or this rule also, right? Okay, it is A to B, current is going downward. So this is suppose this is the screw, and this is the head of the screw, and the moving the current is going downward. So the screw should be going downward. So in which direction I rotate the handle of the screw so that this screw moves downward? So to move it downward, we have to rotate it clockwise. Okay, this is clockwise. If I rotate it like this, then it goes downward. So in which direction I rotate? Clockwise. So the direction is clockwise. If you rotate anti-clockwise, it is going upward. It means it is going upward. It means this is the not direction of magnetic field lines. In that case, the screw should be going downward. So we rotate like this, and this direction is clockwise. So clockwise is like this. Okay, this is a simple scenario. Okay, now the next thing is solenoid. What is solenoid? A solenoid is just like a bar magnet. It behaves like a bar magnet. But what is solenoid? In Hindi it is called परिनालिका, वैद्युत परिनालिका. वैद्युत means इसमें बिजली जा रही हो, करंट जा रही है, ठीक है? Okay. The solenoid is a long coil containing a large number of turns of insulated copper wire. It is a long coil, एक लंबी सी coil होती है, containing a large number of turns, उसमें काफी ढेर सारा turns लगा है, एक तरह का cylindrical core होता है, cylindrical core, बेलन, cylindrical core होता है. It contains a large number of turns of insulated copper wires. तो insulated copper wire को हम large turn लगाते हैं. टर्न्स मतलब घुमाओ, उसके फेरे इस तरीके से. इसको बाद में अगर ये निकाल भी देते हैं तो कोई फर्क नहीं पड़ता है, ठीक है, कोई फर्क नहीं पड़ता. और जितना ज्यादा if the turns are very close then the strength of magnetic field is strong, and if the current is higher in the wire then the strength of magnetic field is also strong, right? Okay. So solenoid is a cylindrical core at which a large number of turns of insulated copper wire is, right? Okay, okay. So this is the plus, this is minus, this is plus, this is minus, and the direction of current is okay. इस तरह से नीचे आएगा, ऐसे गया. ये देखिए यहाँ से वायर ये पीछे से आ रहा, फिर ये गया, फिर ये पीछे से गया, फिर ऐसे से आ रहा, एट लास्ट यहाँ पे इस तरह से आएगा, ठीक. ओके. And here you can see the diameter of the solenoid and the length of the solenoid. Can you see the difference? Can you relate the both dimensions? Length is greater than diameter. So to be a solenoid, the length of the solenoid, the length of cylindrical shape solenoid should be greater than its diameter, right? It can be asked in MCQs, so I want to tell you. Okay. So what is the direction inside solenoid? Inside or outside solenoid? What is the magnetic field pattern around it? This behaves like a bar magnet. So a solenoid is just like a bar magnet. It has two poles, south pole and north pole. Right? Sorry. How we know the polarity of the solenoid? The ends, here are two ends. One is at my right side and another is my left side. So what polarity it has in its both end? So as we know, in a bar magnet there is two poles, there is two ends. So two pole, north pole and south pole, and the magnetic field lines goes from north to south, and inside it north to south. Inside it goes south to north, right? I have to write north here and south here, so don't confuse that north should be written here and south should be written here. Don't worry, there is no issue of direction. We can manage direction on the paper according to our representation. Okay, so this is the direction. So like that, this is. Here is also a closed magnetic field. Magnetic field lines are always closed. So this is the direction, and at the center, the magnetic field lines are very straight. This is the direction, right? This is the shape of the magnetic field. And just wait a minute. Just wait a minute. I am telling you that how to know the polarity. Then when we know the polarity, then we know the direction of magnetic field, because we know that magnetic field lines goes from north to south. If we know this is the north, this is south, then the magnetic field lines north to south. If this is north and this is south, then the direction is north to south here, right? Okay. So to know this, there is a rule named clock face rule. Clock face rule. Clock face rule. Okay. So I have two circular loop. Right. I have two circular loop, and in this circular loop, current is going in clockwise direction. And in this loop, current is going in anti-clockwise direction. Right. So when you see a loop facing at you, and that face is seen, the face which is seen to you, and you see the direction of current is clockwise, then that face behaves or generates like south. If the face on which you see the face which is seen to you having a current in the direction anti-clockwise, then the polarity of that face is north pole. So this is the north pole. The direction is here. Okay. And this is the south pole. When the current is in clockwise direction, clockwise, then that face behaves like a south pole. If the face has anti-clockwise direction of current, then that face behaves like a north pole. This is very simple. I am not going much deeper. Right? Okay. So this is the clock face rule. Simply, this is the clock face rule. What about the other face? If this is the face seen able to you, then the other face is south pole. It is not unipolar. If this face behaves like north pole, then the face behind this behaves like a south pole. If you see the current is going in anti-clockwise direction, then another direction when you see the face of that particular loop in from another side, then you will see the direction of current in clockwise, right? अगर आपको घड़ी ऐसा कोई रखा घड़ी आपने, आप दोनों तरफ ट्रांसपेरेंट है घड़ी, अगर एक तरफ क्लॉकवाइज घड़ी चल रही है ऊपर से देखने पर, तो नीचे से देखने पे वो एंटी क्लॉकवाइज चल रही है। क्लॉकवाइज एंटी क्लॉकवाइज है इधर तो नॉर्थ पोल, यानी पीछे क्या होगा, फिर क्लॉकवाइज दिखाई देगा आपको। जब उधर से देखेंगे करंट डायरेक्शन में क्लॉकवाइज तो साउथ पोल हो गया। तो इसी तरीके से यहाँ पे ये देखिए, ये करंट डायरेक्शन ये है, करंट डायरेक्शन काले पेन से बनाई गई है, और ये तो मैग्नीफाइड लाइन डायरेक्शन। तो यहाँ पे जब आप देखेंगे तो यहाँ क्या बनेगा, यहाँ करके देखेंगे तो ये देखकर इधर नीचे क्या आ रही है, ये हो जाएगा हमारा क्या नॉर्थ पोल, और इधर करंट ऐसे ऊपर की तरफ इस तरह से जा रही है, क्लॉकवाइज डायरेक्शन में जा रही है, ऐसे देखिए ऐसे जा रही है, और इस लूप में ऐसे निकल रही है क्लॉकवाइज डायरेक्शन में, मतलब साउथ पोल हो गया, और करंट डायरेक्शन पे ये हो जाएगी, ठीक है, नॉर्थ से साउथ, ठीक है। सो दिस इज द होल सिनेरियो। आई थिंक यू हैव enjoyed this class. Okay, thank you so much. We will meet in next video.